will devote the entire Tuesday session for tutorials. Is this okay, or we will do only 2 hours meeting? You tell.
Sir, doesn't that depend on the number of doubts?
That's true. That's true. Okay, that's true. You are very practical. Okay, so maybe let us start with the plan that we are going to meet on Tuesdays. Later, if we see that there are many doubts, then we will use another session, maybe Monday or Thursday, something like that. So for the moment, let us decide to meet weekly, Tuesday on Tuesdays at 10 a.m. Okay. Okay. So that is the first thing. I will send you the team code so that you may join, and please do join. And what next? This is the textbook that we will follow, Dexter-Cozen, Automata and Computability. I think, okay, this is not an impressive page, but let us go to Dexter-Cozen's page. So this is Dexter-Cozen in 2016, in 2004, 1985, in 1970. Okay, so we will follow this book. As far as I know, Indian editions are no longer available for this book. But anyway, you know how to get e-editions. There are some other interesting books, Lewis Topazimitriou, Hopcroft, Motwani, Ullman, Sipsar. Maybe the first 3 are the most important ones, references. But we will more or less religiously follow this Cozen style and organization. Okay. Okay, so that's it.
Sir, is this book available in the library? The Dexter-Cozen?
I hope so. I hope so. Okay. Incidentally, this is a book from Springer. So if you are in the campus, you can download this book because we have full subscription to Springer's ebooks. So, in fact, yeah, so for us it's not an illegal matter. We can download any Springer book. Okay, because we pay them. So, you can go ahead and download and share among yourselves. Incidentally, let me know how many of you are in the campus. A brief estimate, rough estimate.
I think around 10 to 15 are not on campus.
Other than that, everyone is on campus. Okay. Okay. So I see that 59 hands are raised. Oh, okay, okay. Who are in campus? I see, I see. Oh, I see. Okay. Okay, so that's interesting.
They just came back in the 29th to 30th slot.
Okay, okay, okay. Oh, of course. You are their faculty advisor, so they must know you.
Yes, yes.
Yeah,
Yes,
yeah.
yes, they know.
Yeah, they must know you. Yeah. Okay, so it would have been a better semester if we could meet and teach physically, personally. Anyway, the COVID situation is not very good. some request came anyway. Anyway, so let us accept whatever has happened. So this is the book. Test schedule we currently do not know because we have not received any directive from the institute. I believe it will be something like last time. So they will give some 3 weeks for conducting the tests. So we have to proceed like that. And what else? What else about logistics? I do not see much more.
So, Professor Das, just one thing I wanted to clarify. Will the Google form again be circulated so that they can tell them that, so that they can tell us the doubts from beforehand?
Yeah. We will do it. So maybe after the class, maybe in an hour or so, so you will see some updates here under coverage. So you will have the Google form link, video links, also maybe scribes or slides, whatever we have available. Okay, so we will do that. And yeah, so that's more or less about logistics. So do you have any questions about this logistics?
Excuse me, sir.
Yeah.
Sir, I had a request from previous semester we had seen that the recorded videos means we find it a bit difficult because we usually get some time and then we rush through the videos. So won't it be possible to conduct live classes?
Not impossible, I would say. We can do that. So if that is the general demand, we will go ahead like that. That is also possible. You tell.
So live classes are better.
Huh?
Yes,
Live
live classes are better.
Live classes
Better.
are better. Live is better.
Live classes are better, sir.
Life class is better. Okay, then we have to let it go in a different manner. Yeah, we can take live classes, no problem. But then we will not post the videos. And since doubt clearance will be automatic during the classes, it will not be like that last time. Okay, so shall we go ahead with live classes?
Yes,
We
sir.
can have it,
Yes.
no problem.
Yes, sir.
Yes, sir.
Yes.
So when
Yes,
the situation on campus improves, so sir, at that time can we have hybrid classes?
What?
So when the situation in the campus improves, like the cases come
Yeah,
down
yeah.
in the campus, so can we have hybrid classes then?
It depends on what how goes, how state government issues directives and the institute says. We can have hybrid classes. We have actually booked to Nalanda classrooms for conducting these live classes. These physical classes. This didn't happen anyway. There is a sudden increase, particularly in West Bengal, Maharashtra and similar places, of COVID cases. And yeah. Okay, so if we have live classes, then we have to, the logistics will be different. Okay, we will record the lectures in the this Teams session, and you can download. Whoever is not present in the campus and unable to join the classes, they can download. Okay. That's more or less fine. So, okay, then let us plan this semester this way, live classes. Okay.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Okay, sir. No problem. Then definitely the videos are also there, so you can go to the previous year's page, and the videos and the things are like this.
Let me tell you about this amazing opportunity. Right now, they're having one of their biggest sales of the year. So अगर आप घर
Okay. Anyway, okay. So if that is the case, what shall we do now? Shall we start from Thursday, or I will give you a brief introduction today itself?
So Thursday is better, sir.
Thursday is better.
Yes, sir.
Okay. Okay, then let us start on Thursday. So, but I want to give you a brief, I would say, idea about this course today itself. So I will not write anything, just tell you what we are planning or what this course is about. So we deal with computers, right? So these are some kind of machines, and like other machines, like you say an airplane, an electric motor, things like that. Each machine has a purpose. Okay. Airplanes are used for flying, transportation. The electric motors are used for rotating things like fans and many other things. Okay. So we deal with computers. So what kind of machines are these? So this is the basic question. Okay, in this course. But for that matter, we first need to understand what kind of problem it is going to solve. Okay, airplanes have a specific purpose. Then electric motors have some definite purpose. Okay, so now the question is, what purpose these machines are going to solve? In other words, what is essentially meant by computation? Okay, so what problem we are going to solve? This is the first question. Okay, then we will tell how to do it. First what and then how. Okay, so that involves some kind of formalism. The reason is that if you look at your desktop computer, laptop computer, or even cell phone, these are all computers, and computers are there embedded in many systems, even watches, smart watches, and every other Internet of Things. But these so-called computer architectures are pretty, I would say, complicated. Okay. Of course, you need to know how modern machines work, but these issues will be covered in other courses, your system-oriented courses like it starts with switching circuits and logic design. Then you will study computer architecture to look at the hardware perspective and how you use this hardware. Maybe to of course, given the hardware, you cannot do perhaps nothing. So you need some interface. So operating systems, compilers, and computer networks also. These will be covered in your curriculum later. Okay, but these are practical things. In this course, what we will do, we will theoretically model what is meant by computation and what is meant by computers. So computation is essentially the first part of the course name, formal languages. So we will define languages, we will define the membership problem, so-called decision problems, membership problem, finite representation and all that stuff. So that will define the process of computation, what we want to do. And the second part of the name, automata. Automata is the plural of automaton. So these are like computers, but these are simple mathematical models. We will start with a very simple kind of language recognizers called finite automata. So these are very simple machines and they can do some amount of computation but not much. Okay. Still, these are very interesting and important because this finite automata are directly linked with so-called regular expressions, which have several uses. In fact, in your systems programming lab course, which will be online, and okay, also we will do some kind of live sessions like this. We will look at something called GREP, GNU regular expression finder or something like that. Okay. So this is followed by what is called context-free languages and context-free grammars. So this part is very, related to compiler design. Compilers or the C programming language or C++ or whatever you say, these are not context-free languages, but there is a part of the compilation process called parsing, which is basically done in a context-free manner, whether your program is syntactically correct. Okay. After that, you go to details, the meanings of your variable declarations, your loops, variables, functions, and all that stuff. So, but on the top of everything, the grammar is usually defined in a context-free manner. Okay. So we will study context-free languages next. Then there is a class of languages which we usually do not have time to cover. These are called context-sensitive languages. We will not cover this. Maybe we will give you a bit of exercises on this. But then we will jump to what is called Turing machines. Okay. So in mid-1930s, Alan Turing of Oxford University, if I am not mistaken, Oxford or Cambridge, I think Oxford. Anyway, so he proposed a theoretical model of computation and computers, or I would say at about 2 decades before the real computers were even built. Okay. So these Turing machines are very powerful machines. They are very primitive machines, but because of this primitiveness, we can analyze these machines mathematically. And what is important in this context is that your, laptop, desktop, even servers, even big, I would say, supercomputers, they may seem more powerful, but at the end we will see that these Turing machines, although they are very simple machines and very primitive machines, they are essentially equivalent in computing power with all these modern computers. Okay. In other words, the notion of computation, computers, and computability, what is computable, what is not computable, these notions are already present in this simplified model called Turing machines. And since Turing machines are simply describable, we have good understanding about the computability issues. Particularly, we will see some kind of diagonalization proofs and some kind of reduction proofs. And if we want to do the same kind of proofs for modern computers, like your laptop machines, it will be very difficult. Okay. So, this course is once again going to be a bit theoretical, not immediately applicable to other branches of computer science. But as I mentioned, formal, what is that called? A finite automata have some applications. Context-free languages do have some applications. And finally, Turing machines are the ultimately powerful machines, as powerful as a computer can be. So we must learn them. Okay. So this is basically the roadmap in brief. We will first study so-called regular languages, then context-free languages, and finally so-called recursive and recursively enumerable languages. Okay, so yeah, that's how we will do, and most of the textbooks that we have seen, they proceed the same way, and this has become more or less the standard way of introducing formal languages and automata theory all over the globe, and we will follow Cozen's style and I would say organization. Okay, so this is a brief introduction to the course, and what I suggest, okay, anyway, let's see. Since we are going to have live sessions, I am tempted to ask you to look at the first video, which covers essentially nothing but a motivational video. Maybe I will start from the second video, languages, strings, and all that stuff, with a brief introduction why we are studying strings. Anyway, we will do a live session, no problem. Okay, so I would say that we are not going much beyond this today. Okay, let's see. If you have any particular queries at this moment, of course we have not told much, but anyway. In fact, I am not recording today's session. It's not very important. I will mail you the team code and the course page URL. Okay, then if we have live sessions, let us plan this way, which we did 2 years ago. So Monday and Tuesday are your regular, I would say, classes, and Thursday will be your tutorial session. Is that okay?
Yes, sir.
Yes, sir.
But of course, this Thursday we cannot have any tutorial because we have not covered anything. So I will give an intro on Thursday. And the proper material will start from next week, maybe. Introduction means motivation, what are called languages, things like that. Okay. So Thursdays will be tutorial days. Monday and Tuesdays will be instruction days. Okay. Only this Thursday we do not have enough material to do tutorial. Yeah, so let us plan it this way. No problem, right? And yeah, if maybe after a couple of months or so the COVID situation gets normal and we can have physical classes and the institute gives us permission to do so, we will have it. Anyway, we have booked 2 classrooms. Yeah. So, any query at this moment?
Sir, is there any kind of doubt, sir, can we meet you at your office by taking permission, prior permission?
Of course you can, and you will find me in my office in the afternoons, usually not in the morning. Okay, afternoon, even early evening, maybe as late as 10 p.m. or so. I am a little bit late riser. Okay, my day starts late. But you will find me in the afternoon, maybe 3 p.m. onward. And if you are permitted to enter the academic campus, please come. No problem. Absolutely no problem. Yeah, any more query? Okay, if not, let us close this introductory session for now. We will meet again on Thursday. But I am going to meet you again today afternoon, 2 o'clock, for the Systems Programming Lab, along with Professor Gupta. Again, we will start with some introduction and little bit exposition on computers or other compilers, the GCC compiler. But anyway, okay, so shall we call it a day now?
Yes, sir.